I think we'll start. Hello, everybody. Good morning, and thank you so much for joining us today. My name's Suki Sandar. I run the technical pre-sales teams for SingleStore across the international region. I've got a great presentation which we've prepared for you today. I promise you, if you give me 30 minutes of your time, that you'll absolutely learn something and take away something from today's presentation. I'm co-presenting today. I'd like to present my co-presenter, Sunil Odonwala, who's going to join me a bit later on stage. Today's presentation is all about the power of unifying data. But before we do that, I'll take you through 2 or 3 parts of who my company is, what we do, and why you should be interested. After the first kind of 5 or 6 slides, I'll hand over to Sunil, and Sunil will take you through their data journey and what they've gone through with SingleStore. I will come back at the end and just kind of wrap up really quickly. We'll leave about 5 minutes for questions, but here's the great news. If we don't get to the questions, our stand is the first stand as you get outside of the theater on your right-hand side. Okay? So a bit about SingleStore, and I've tried to boil this down, a bit like mountaineering food, so that you get all of the goodness, but in a small package. So I'm going to talk about what is SingleStore, how are we different, and why should you really care. So SingleStore is a real-time distributed SQL database. We do something very different than most databases. We are a unified database. Lots of people have started talking about this now. And what I mean by unified is we're bringing together a transactional OLTP database and a slice and dice COM-store database. And that's unique. I know it's unique because it's a patented technology, which I'll talk about a bit later on the second slide. We are a distributed SQL database. So we are cloud native. Distributed SQL is something that now a new set of kind of 3rd generation of databases are talking about. So instead of kind of the 1st generation, which was typically a single node SQL database, we are a distributed SQL database, which is a very different generation of SQL databases. We execute quite differently than most databases. And the difference is we don't cache any data. We pride ourselves on running queries directly on the data that's inside of the database. So we don't provide any kind of cached results. We execute low latency SQL, distributed low latency SQL over the existing data that's in the database. A very different way of executing, and especially when you're talking about low latency. Here's what's really different. All of the value, the TCO, the ROI really comes from this unique architecture. And if there's one thing that you take from this presentation, from my part of the presentation, is this slide. In most architectures, you typically get either a row store in-memory database to handle your transactional data, which is stored in a very separate place than a slice and dice analytical database. And in between, typically you have an ETL layer. So it takes the data from a transactional database, you take it into a different technology, you take it through an export, transform, and load process, and then you put it into an analytical database. Typically, when you're moving data from one data store to the other, it adds latency to the data. And by the time the people that want to consume the data, the analytics teams, the data scientists, the marketing people, the salespeople, by the time they see the data, it's usually at least 1 hour, maybe 24 hours old. So the architecture we're talking about here is defined by a single table type in SQL, and the table is a COM-store table with a row store segment, and that row store segment is pinned into memory. So it is a very different architecture. It's quite transformative. in the way organizations will look at how they want to change their data platforms that they've got in place. We typically bring multiple different databases, data platforms together, and we do in-database ETL. Okay, so that's what is single store and why is it so different. Actually, the universal storage concept, which is this single table type, which is a column store and row store table, is actually patented. And that's why I know it's unique and nobody else has got it. So why should you really care? Well, if you're looking at a combined unified database like single store, typically with a single table type, we tap into 3 different layers of storage systems. The first storage system is the in-memory row store, which is like the top tier. The second tier is column store, which is optimized and stored on disk. And the third tier is this kind of object storage, which is cool storage. The beauty about the technology is you don't care really where the data is. You let the technology, you let SingleStore manage the movement of data between these 3 layers, and we do that based on a whole host of different inputs, mainly from the people that are consuming the data. So we will decide what's in row store, what's in column store, and what gets pushed down into cold storage systems. So there's this concept that most architects have of kind of hot data, and hot data is in memory, warm data is stored on disk, and then cold storage systems are kind of object store style of systems. We fit into that architecture, but the great thing here is it's a single architecture, not multiple different technologies. I come from a background where I've spent 20 years building in-memory databases, and then moving that data over to analytical databases. This is not that architecture, and this is why I came to SingleStore. It's a completely different way of looking and storing data. What are we really good for? So what is the sweet spot? Why would you really care? There's kind of 3 key attributes of a problem that organizations would come to us for. You either want to take high-speed data and not take it through an independent layer and push that streaming data directly into a database. You do that through a pipeline technology we have, using things like Kafka or S3 buckets. You then want to execute low latency SQL analytics over it, and those could be SQL analytics coming from any type of analytical tool. We're not an analytical tool. We kind of have adapters to all of the kind of great analytical tools out there. And the third thing is, as you're streaming data into the row store segment and into column store, we're not blocking or locking any of those tables up for any analytical tool or capability that wants to get access to it. So we're running a multi-version concurrency control at a row level. So as you're streaming the data in, anybody who's running SQL and analytics can look at that data without blocking anything. So it really is built very differently than a conventional architecture that you may be used to today. Finally, before I hand over to my co-presenter, kind of what makes SingleStore unique, these 6 things. First is the universal storage concept, which is the patented table type, taking advantage of those 3 storage systems. Unlimited storage using object store, fast ingest without having to go through an intermediate layer, so you're streaming data directly into SingleStore. We are multimodal, but we're a relational data store. So you can push JSON, you can push time series, geodata into SingleStore, and we'll store it as a relational structure so that you can execute over it using standard SQL. We run anywhere, so where you can manage this software yourself, so kind of on-prem or private cloud using the software itself or Kubernetes operator, or it's a managed service, which is multi-cloud. And we are standard SQL compliant. And with that, I will hand over to my co-presenter, Sunil. Thank you very much.
Great, thank you, Suki. Thanks everyone for attending. I'm Sunil Odedra from Kurtosis, I'm the CTO. I'm going to speak about our journey with SingleStore, how we adopted the technology and how we use it today. So I'm going to speak about a time period that spans about 6 or 7 years. That's how long we've been using it. So First of all, about Katosis. So we're based in London. We're founded here. These days, our team is distributed around the world. So we've got offices all over the place, including Raleigh and Cape Town. What we do is we create digital solutions for investment managers. So they effectively give us their data, we sanitize it, and then we can do different things with it. And we have 3 production regions for data sovereignty reasons. So we run a production region in the UK, in London, the US, and mainland Europe in the EU as well. And each one of those production regions runs single store DB. So a little bit more about how our platform works. So we can store and manage data and documents that our clients provide us. And then we can basically use all of that content in different ways. So we can build public websites with public fund information, or we can build private, secure websites with investor information. These can be used to then present all of that data and documents in different ways to our clients, all in real time via single store. And we can also then use it to create distributable formats like PDF reports that can then either be presented in those portals and websites or sent out to clients. So this is first I'm going to describe our previous architecture, what I would describe as our legacy architecture. It was primarily based with SQL Server as a database technology. We had a level of multi-tenancy support, but it was based on a database instance per tenant, per client. And that's how we had client data segregation. And we also had a custom reporting engine that was based off of that. Again, it was legacy and it involved writing a lot of bespoke SQL queries. And there was a website CMS as well that would then be used to publish that data from our platform. We knew there were limitations with this platform when we went down a journey of modernizing, and we looked at what was out there on the market and all of the different options. So the first challenge in terms of modernization, the thing that we were trying to solve, was scaling our platform and improving the performance. So as we dealt with larger and larger client data sets, we had to scale our SQL Server infrastructure, and it was sized for peak load. A lot of the reports would run monthly, and we were sizing based on that. And then there were also certain performance bottlenecks with some of the reporting queries that we had to write, and we were starting to run into those problems as we had more and more customers, and we're running more and more complex reports. We're also looking to adopt cloud infrastructure. We were beginning to look at private and public cloud infrastructure at the time. We were still creating our own servers back then, right? And that was another area of modernization that we were looking to adopt as well, including all the automation that went with it. And finally, we wanted to make an API-first architecture. So we still had a lot of processes that were writing and reading directly from the database, and we wanted to move away from that and have all of our applications go via our APIs primarily, right? Both for our own applications, but also to expose APIs for our customers also. So we ran into a number of challenges. I think these may be familiar to some of the people in the audience. First thing was our team was primarily using a Microsoft stack, and we were adopting new technologies that were using open source technologies or running on Linux, and we're also adopting non-Microsoft technologies and the cloud for the first time. So that was the primary challenge. Then we also had a lot of custom data ingestion processes, which were writing directly into SQL Server. They're all bespoke, and those needed to be modernized as well, and again, using some of the APIs that we were developing. Final part is we were receiving structured data from our clients. We were quite happy with using a relational database, and that's the technology that our team was familiar with. So the first thing we did is we went down the path of looking at different NoSQL engines. Again, something that might be familiar to a lot of people in the audience. There are a myriad of technologies out there. They're usually grouped into these 3 areas, and you have to pick the right type of NoSQL engine for the type of problem that you're trying to solve. And sometimes that means introducing more than one engine to your platform. That also introduces some complexities with your infrastructure setup, the knowledge levels in your team, as well as your architecture. So there were several systems that we liked. They were all good for solving specific problems, but we couldn't find any single solution that did everything that we wanted to. They're all complementing the existing architecture or solving certain problems. So the next thing is then we came across a technology called MemSQL. So usually when I'm with Suki or Alex from SingleStore, they tell me off for calling it MemSQL. This is the first time they've allowed me to use that name, but the technology was originally called MemSQL. And it was promoted as an in-memory relational database system. Since then, it's been rebranded to SingleStore as the platform has matured and additional features have been implemented, and we effectively made it our primary store along that journey, along that timeline as well. So back when it was MemSQL, it was promoted as an in-memory relational database system. So it had some of the benefits of a NoSQL system, so it was distributed across multiple nodes. You could scale the platform in that manner, but it was still fundamentally a relational database where we could create tables and we could write queries against them. Okay? So it helped us significantly with our performance because all of the tables were in memory. This is back in the time before SSDs really became cost effective, either in a private cloud or the public cloud or with your own setup. So disk performance was a major factor and a consideration. The other thing is, because the cluster was distributed, we could scale it. We didn't have to size it for peak load. We could actually scale it on demand if we needed to. It was also highly available as well. And then, as I said, we were familiar with the way that our teams wrote queries against it because it is fundamentally a relational database system. So it was far more natural for us to migrate some of our existing workloads and our existing queries, even though the syntax was different. So the onboarding period for our dev team was much simpler. The next slide shows what our initial adoption of MemSQL, as it was known back then, looked like. We initially used it as an in-memory cache, so we were still using SQL Server, but we had MemSQL sitting above it and in front of our APIs. So all of the reads went via MemSQL, so we gained from the performance benefits of the fast queries that our APIs were able to make, but writes went back to SQL Server. We wrote a custom sync process using change data capture in SQL Server, so we'd handle those events and we'd synchronize that data through to MemSQL. What that meant is it was operated as a cache, so if we lost MemSQL, we could easily rebuild it. We would create a new cluster and populate it with the data in SQL Server. We didn't have all of the data from SQL Server being synced through to MemSQL. It was just the active records that we needed to query through our APIs. And the schema was also not exactly the same, right? So there were certain tables that were left out because we didn't need them in memory. There were certain changes to the tables as well. And we could also limit which data we wanted to send across. So that worked for us. That gave us some of the performance benefits, but there were still complexities involved with this architecture. We still had writes going back to SQL Server. We still had ETL processes going straight to SQL Server also. And it's not depicted in this diagram, but there was another NoSQL technology along the side as well. So we didn't introduce some of the benefits, but we felt our architecture was still a little complex. But MemSQL, as it was back then, didn't really have everything that we required. So in that setup, there are a few things that we learned. So first is the option around sharded tables and how we had to consider our schema and the way that our data was distributed. So our team began to factor in that in their design, and that was a consideration in their approach. And also we could handle multiple query sources. So reading and writing to different systems was quite complex because for all the reasons I outlined in the previous slide, there were a lot of problems where sometimes the sync process would pause or it wasn't fully up to date, or there would be a delay. And so we had to develop that over a period of time where we would force writes to happen in both systems at the same time, where initially it was a sync. So having those two database systems in place meant that we had to write to two places as well after a period. And the costs were high as well because we were running two database platforms. So as MemSQL became single store DB and the features developed, we started to adopt more and more functionality. So some of the key improvements were the support for JSON columns, right? So we could, where we were storing certain entities for our clients, we could extend them through the use of JSON columns, and we could query them using the regex syntax, and that was highly performant. We also adopted the column store tables, which allowed some of our data sets to be stored on disk. As you saw, Suki outlined the 3-tier architecture. This is the second tier. What that also meant is it allowed our clusters to scale in a more cost-effective manner. We didn't have to have all of the data in memory. So some of those data sets that were still being housed in SQL Server, we're able to migrate those to single store as well. And finally, support for stored procedures was much appreciated. That really simplified some of our code as well. So as those features expanded, we adopted more and more functionality on single store, and it did actually become our primary store and our primary database technology. The current setup looks like this. It is our primary database. There is no more SQL Server or sync process. All of our reads and writes go to single store. It's self-managed, so we're not using managed service, but we've adopted the technology, and we've developed all of the automation and operational aspects that go with that. We run on AWS, so all of those 3 regions that I outlined before, they're AWS regions, and we run in a HA setup, so all of our nodes are distributed across multiple availability zones. So we've had a few questions about that in the past at various single store forums, but we do operate in a HA setup across availability zones. There are no problems with latency or anything in that regard. And it is our primary technology today. So that was a journey we went down, and we'll stop there, and I'll hand over to Suki, or if there are any questions, you can ask now. Otherwise, I don't know how we're doing for time, but the stand is just across the hall. Right?
Thank you, Sunil. Sorry. Technology getting in the way of a technologist. Yeah, I did have one more slide actually, but just to summarize, a single store is a very different way of storing and using data. It is a platform that brings together 3 different tiers of storage systems, but using a unique table type, which is a combined column store and row store table. If you've got any questions, I'll take them now. I think for the first time ever, I'm 5 minutes left over from the end of the slot. So thank you, Sunil, for staying on time. If there's any questions, I'll take them. If not, as you come out of the theatre, just opposite you is the single store stand. Sunil and Andy, who's one of the lead engineers from Kurtosis, are going to be on our stand. So please come and ask us questions. Any questions from anybody? I don't know how to do this really. I mean, I can. Oh.
Testing. Can you hear me okay? Testing. Really interesting talk. Would you say single store could it potentially be used as kind of a back end to be requested by a front end? So say for a website, for example, that's serving up data on the fly. Or would it not be fast enough?
That is the whole point, is to bring together kind of customer facing data stores and analytical stores. So you're probing the same database, which is the big difference. I mean, many architects will say, frankly, we don't believe you. And that is right. Actually, I mean, I've been through, 15, 20 years of architecting data stores where you keep the operational stores separate from the analytical databases because you don't want the transactional systems, the operational systems, to be affected. So we really are getting out there and saying something very different, which is why I started off on saying it is transformative, right? I mean, it's a very different way of thinking. We've spent probably best part of 20 years building different teams who look after operational data stores, and the teams of data engineers which take that data, massage it, and then make it available for the people who want to consume it. So it is a very different way of looking at an architecture, and it's not specific to any particular data type. What we're saying is, hey, it's a multimodal database, but it is a relational database. So something that most architects have grown up with and are used to managing and working with. Thank you for the question.
I guess what I wanted to ask was, I'm quite new to this whole data thing. And so I spoke to you guys I think half an hour ago, and I went across and I spoke to Starburst.
Mm-hmm.
And what Starburst, for those who haven't been to their stand, they essentially take legacy databases, let's say they take 100 of them, and then they layer their technology on top. So effectively, you can query everything in one source at the same speed. Now, I guess my question to you is, have you faced this challenge that companies are less willing to migrate to single store because they've got this option where they can just do it immediately?
Great question. So some of our, I don't know if you want to put your headset back on, can you hear me? So some of our biggest customers globally are joint customers with Starburst. So Comcast in the US, Retail Bank in Europe, who I can't kind of name publicly, but they have Starburst kind of above, and Starburst is providing the security, the single access to multiple different data stores. We're not a legacy data store, but the organizations put single store in place because there's less movement of data. And actually, you can operate in different ways with the Starburst team. Great technology, by the way. Starburst will either generate SQL, optimize SQL for the data stores, or it will allow platforms like SingleStore to do that for you. So we're actually much faster in most instances than the generated SQL that Starburst would provide to us. So, like the retail bank in Europe, they ask Starburst not to change anything and just push down to SingleStore, and SingleStore will do the execution of the SQL, the low latency SQL across of our platform. So we've got some great architectural customers which have Starburst and SingleStore collected. I mean, big customers that do that. So I'd love to talk to you more about that and why that's a great architecture. Most architects now are looking at grid style architectures and having a data virtualization layer, a management, security, access control layer, which then sits above the databases underneath. And that's the kind of architecture that we fit into. We don't provide the data virtualization layer, but we're a combined DB, we're a unified database. Thank you. Thanks for the question. Great question.
Hi, can you hear me?
I can, yeah.
So what kind of support do you have for running things like Python or R workloads inside the engine itself?
Yeah, great question again. We several different answers, like most technical answers. The options, there are options, so it depends. So we've recently launched a WASM interface. So I don't know if you know WASM. WASM is a WebAssembly language. It's pretty new, actually. And what WASM allows you to do is develop in any language. It's a open source interpreter. And what you do is you can push down the language, the execution into the database in a secure, managed way. So we've just actually, the last release out of the last one, we introduced WASM integration. So you can develop in any language, C, C++, Rust, all of these different languages, and you can push that down to where the data is, and use the highly distributed architecture of single store to execute that data and then bring it back up. It's it's quite a newer way of working. I haven't got a WASM background, but if you have, I'd ask you to do that. And then also, before we introduce WASM, we have many different libraries which allow you to kind of integrate different programming languages into single store, Python, Java, other languages. WASM is the technology that's really allowed to, in a secure manner, push executed logic inside of the database. And with that, I think we finished. Thank you so much for your time, and have a great show. Thank you very much.